Hello, Bridge. How's it going? It's week 5. We're doing great. You're doing here. If you're here so far, I appreciate it. Keep working, keep your head up, keep doing what you're doing, all right? Let's get started. I got a bridge of the day. It looks super duper cool. It is in Athens, Greece. The Plaza Bridge. Pretty darn cool. All right. Today, we are going to continue solving exponentials. Last week in 4.2, I gave you some exponentials, and all of them were exponential growth. So now we're going to look at exponential decay. I mean, it's the same process, but there's going to be a little bit more decimal work here. Okay, so I've got 3 problems for you, and I have, again, 3 problems for you on the homework. So since they're word problems, they are a little bit longer, and I'm going to ask you to show some work. So here we go. Let's just get started. Before we get started, I want to remind you that we have like 2 different ways, or there's like, this is like the form. Sorry, let me actually get started here. This is the form that we're going to be using when we solve exponentials. We've got A equals an amount after a certain amount of years. P is the principal or the initial value, whatever we're starting with. And then we have 1 plus or minus R. Again, R is a rate, a percentage as a decimal, and then T is just a time period after so many months, after so many weeks, after so many years. And then this inside 1 plus or minus, again, you're doing 1 plus R if you recognize that it's a growth problem, and 1 minus R if you recognize that it's a decay problem. And hint, since we're going to be working with a lot of decay problems today, they're all going to be 1 minus R. And then we also need to have logarithms in order to solve our exponentials. And if you remember, we had like logarithm form, log base b of a number equals c. And you could go back and forth between this logarithm form and exponential form. So this is really saying b raised to the power of c is equal to a. All right, so here was our logarithm form and our exponential form. We're going to need these 2 ideas going forward today. So let's look at this first problem. I'm going to be highlighting specific things that we're going to need. You buy a new computer for $2,100, and hey, that's the number. Let's figure out what that's going to be. You buy a new computer for $2,100. So that sounds like my initial, that's my starting price. So that's my principal amount. The computer's value depreciates. Okay, this word depreciates is always going to indicate decay. Like literally the textbook, or like, I put it in Webster or whatever, and it said, your value is going down after some amount of years, right? So this computer, as you use it more, it's going to get crappier, basically. And then we have 50% annually. So that's our rate. And I'm going to just take that 50% right now and write it as a decimal. I'm going to move that decimal place over twice, so 50% as a decimal is 0.5. When will the computer have a value of $600, right? So after how many years is it going to be worth $600? That's my A amount, right? So if I use this formula, A equals P times 1 minus R to the power of T, I can just input everything I need, and we're going to be seeing that we're going to want to solve for T here. So my A is $600 equals my principal, $2,100, times 1 minus 0.5 to the power of T. And now we just have an equation that we need to solve using our logarithms. So first step first, I'm going to just get this into a simple exponential. So I'm going to divide by 2,100 on both sides. 600 divided by 2,100 gets me a really long decimal. It was 0.2857, ... It just keeps going. I'm just going to kind of cut it off there. Equals 1 minus 0.5, which I'm going to just simplify down to 0.5 raised to the power of t. Now that this is a simple exponential equation, I can put this into logarithm form and say, all right, as a logarithm, it's log, I have a base of 0.5. Log base 0.5 of 2.85714,286, it keeps going, equals my exponent of t. And then, in order to figure out what t is equal to, I just got to evaluate that. And I can do that using the change of base formula. So I'm going to pick a new base of 10 And I'm going to say log base 10 of 0.2857 divided by log base 10 of 0.5, my original base. Again, I'm just going to highlight these here so we see where those numbers are coming from. And then this right here is something that I can plug into my calculator. Since all the calculators, again, work very well with base 10, I can just literally type in log 0.2875 divided by log 0.5. Make sure you're getting a number. I got a number of about 1.807354922. That's a 2. Anyway, so, and kind of rounding it off, let's just round it off to the nearest, to go out 2 decimal places. That sound good? So it's about 1.8 years. So almost 2 years, and this computer is going to be worth less than $600. Okay, let's move on to another one. Drinking coffee, all right? Drink a beverage with 125 milligrams of caffeine. So right now, after you've drank that, you have 125 milligrams. So that sounds like my starting value. So I'm going to say that that's my principal. Each hour, so there's like a time period. Each hour the caffeine in your system decreases. There we go. That's our decay indicator, right? It decreases by about 12%. There's our rate. Again, 12% as a decimal. I'm just going to move that decimal place over twice, and I'm going to get 0.12. How long until you have 10 milligrams of caffeine left in your system, all right? So that is our, amount after some amount of time period, and we're going to be trying to solve for time, right? How long? So I'm just going to write out that basic little 1 minus r. There we go. I'm just going to write that out. Now we can just start plugging in the pieces that we know. I know after some amount of time we should have 10 milligrams left in our system. Our starting is 120, 1 minus our rate of 0.12, raised to the power of t, what we want to solve for. So again, first step first, I'm just going to divide by 120 on both sides. And this over here on the left-hand side gets me a decimal of 0.0838383, repeating forever. And then those cancel out. What I'm left with is 1 minus 0.12 to the power of t, which I'm just going to simplify down to 0.88 to the power of t. And then this is a simple exponential that I can write in logarithm form. So I'm going to have log base 0.88 of 0.083838383 equals t. And then again, using your change of base formula to evaluate that out, well, I'm just going to say, let's pick a new base of 10 so we can use our calculators. Log base 10 of 0.083 divided by log base 10 of 0.88. And that evaluates down to about 19.4386. And so I said, all right, roughly 19 and a half hours, and then you will only have 10 milligrams of coffee left. Alrighty. Last one, you're doing great. Hang in there with me. Just practice, practice, practice. So that's why we're going over lots of problems. You're doing good. Okay. In 2010, the populations of a city was 275,000. All right. So there we go. That sounds like our starting value, our principal P. Every year, 25%, there's our rate, moves away, going away from the city. So that would be our indicator that this is a decay problem. And real quick, I'm just going to say 25% as a decimal is 0.25. How many years until the population reaches 100,000? All right, so again, there would be my A value. After some amount of years, we've dwindled ourselves down to 100,000 left in the city. So I'm going to just input all this in. 100,000 equals my principal of 275,000 times 1 minus 0.25, that rate, raised to the power of t. And now we'll just simplify this down here. So I'm going to divide by 275,000. And then this left-hand side, that's a decimal of 0.3636363636 repeating equals, and then 1 minus 0.25 is 0.75 on the right-hand side of the equation, raised to the power of t. Then I can write this in a logarithm form. Since this is a very basic exponential, in logarithm form, I'm going to have a base of 0.75. My answer over there, like the 0.36 repeating here, equals my exponent t. And then I just have to use my change of base formula to evaluate that down. So t is going to be log base 10 of 0.36 divided by, I'll put a 0 so it looks like a real number, divided by log base 10 of 0.75. And then I plug that into my calculator as log 0.3636363636. I just put a whole bunch of 36s in there, divided by log of 0.75, and I got an answer of roughly 3.5. All right. So what was your question? Oh yeah, after how many years? So you got 3.5 years left in the city, and it's starting to turn very small. So they need to do something to incentivize people to live there, because it's slowly dying. People are losing population. Okay, have a great day, you guys. There's 3 decay problems on the Google Docs assignments, so open those up, show me some work, type in an answer, type up some work, however you're going to do it. Rock on, have a great day, and since you've been doing so well, here is a video of my aunt's cat. I said, please send me cat or dog pictures or videos to be featured, and she sent me lots. So enjoy the cat named Storm. He is not a nice cat. I do not like him very much. Have a great day. Bye.